Hello everyone, welcome to this video. I'll be talking about my thoughts on the cognitive function of subjective thinking, in particular systems. Often when I read quotes about systems or hear people talking about systems, I don't fully understand what they're talking about. I think it could be I'm missing something, or it could be that there's some confusion over a system. Initially, when I thought about this cognitive function, I included systems as part of analysis, which is, I think, incorrect. It's separate to analysis. It's not a hierarchy either. Sometimes when people complain about systems, I think they're complaining about hierarchies or talking about hierarchies. I don't think a system's a connection either. Also, it's not a collection. So a toolbox is a collection of tools. Went into some branches of knowledge, systems engineering, systems thinking, and systems theory to come up with a definition of systems. I couldn't find a good one in the dictionaries. So I've got one here, which is a combination. And an analysis of systems is difficult. There's different ways of categorizing it. I've decided to break it into three categories: factors, nodes, loops, and recovery. Okay, here's an analysis of systems, so nodes, loops, and recovery. I've taken it down to the fourth level of analysis here. I'll go through with some examples. And for networks, that's decentralized and centralized. An example of a loop system would be a cycle or an ecosystem. So nature's obviously real. It's made up of objects and fields, and the system in nature is a subject of thought about something objectively real. A circuit, I think, is another example of a loop system, and that's an example of an air conditioning circuit. For networks, the obvious example is a LAN, and for lines, a railway system. So the nodes are called stations. Again, these are diagrams about something real. Okay, an example of redundancy would be a gauge helps monitor an example of a fuel system. Of course, a car has a fuel system, but I don't think a car is a system. For instance, a car has a seat or a fender. I don't think they're parts of a system. But the fuel system definitely is a system in a car, and you can monitor it with the fuel gauge. Obviously, in this example, there's two fuel tanks, so that gives you recovery, and a spare tank of fuel is a backup. It's a very simple example. My reading of the early days of the auto industry is that the production system was a centralized network node, so the motor car was like the central node and the production moved to it. Of course, once the system's understood, it can be developed. For instance, to optimize it, black paint could be used because it dries quicker. The production system could be improved by moving benches closer or further apart. But of course, the production system could be innovated by being changed from a network to a line, which of course increased the amount of production. Of course, an electric light bulb is part of an electric circuit, and this systems thinking is very important, I think, to become cognizant or to become aware of how technology works. That's what I think.